I don't have many new features to show this week, but I've been making some big structural changes behind the scenes, mostly to enable saving and loading. So this seems like a good time to talk about the overall architecture of cargo defense and how I overcame the complications I found with save and load. But first, a few updates. After doing a lot of research and getting some feedback, I've decided to postpone the Kickstarter campaign. The team making cargo defense is also growing, with a second artist and a few volunteers who have offered to help with graphic design, story content, and music for free. This was quite a surprise, and I'm glad to have all the help I can get. I'll make a proper introduction once we've had more time to discuss and get some legal agreements in place, just to be on the safe side. Lastly, I want to make a correction to the tutorial I posted last week. I'll bring this up again in the next part of the tutorial, but I want to correct misinformation as quickly as possible. When I said removing the level node from the hierarchy was enough to get rid of it, I was wrong. I haven't confirmed the reason, but I think it's because references between the level and its child nodes in both directions prevent the ref count from ever reaching 0. So if you are following my tutorial as an example, I recommend removing nodes by calling Q free to make sure you're not leaking memory. But now let's get back to cargo defense. Architecture is an important part of software development in general that I think gets overlooked a lot in game dev tutorials. These are currently the main building blocks in cargo defense. I've left out a lot because there are 51 scenes and 108 scripts in total, but a lot of them aren't very interesting. For instance, every button in the UI has its own script. Overlord is sort of the central director. It owns the universe, and a lot of other things too. It's responsible for major state changes, like entering a space station or starting turn-based mode, but it's also a convenient point of access for everything from the game board to UI overlays. Until recently, this was a script attached to a node in the main in-game scene, and almost every script in the game would use getNode to retrieve a reference to it. But now that I've learned about autoload, that's not necessary. This is now one of 4 singletons that are automatically created at startup and can be accessed from anywhere, from any scene, without even needing a reference to the scene tree. This makes my code much cleaner after hours of refactoring work, but the main reason I made this change was for loading a save from the main menu. When switching to the in-game scene, I needed to carry over information so it knows whether to load or start a new game. Since the one instance of Overlord always persists across all scenes, that made it easy. Another big change recently was moving a lot of code out of Overlord, because it became sort of a dumping ground for way too many things. Specifically, I've moved things to 2 new scripts called UI Layer and Overlays. UI Layer handles things like popping up message boxes and updating information in UI that's always present in-game. Meanwhile, Overlays handles things like the tile highlights, selection cursor, and aiming lines. Overlord holds a reference to both of these, so scripts anywhere can get at them easily without dealing with node paths. As discussed in a prior video, the board holds references to objects in each tile. I've broken out units as a special category here, aside from the rest of the board objects, because they all share a common superclass that handles things like movement, taking damage, action points, etc. Universe is a repository for content, basically. All the contracts in the game, all the weapons and how to get them, all the locations, and all the people that can show up, either as enemies or available for hire. The player class is where I'm holding on to things that might be unique to each player if I ever do multiplayer someday, but that's a big if, definitely no promises on that yet. The person class represents a character in the universe that could get hired by the player, then later dismissed and become a pirate, or vice versa. That's why this is separate from the unit classes. The unit can go away, and the person still exists in the universe unless they were killed. I don't think it's worth explaining every piece, so I'll stop here, but let's talk more about saving and loading. I've implemented this before in other games, but cargo defense turned out to be a more complicated case. There are at least a few different approaches to saving games in Godot. I could save the entire scene to a file and restore it later. That would be easy, except if I update the game and you load a save from an old version, lots of things are likely to break. That old scene could have a different node hierarchy, different variables on nodes, etc. Instead, my approach is based on one suggested by the Godot documentation, bundling all the information I need into a dictionary and serializing it to JSON. The first complication is any references to an object just become a string in the JSON output, and that string doesn't have any of the information you need to recreate the object. So every variable that references an object needs to be converted to something that will still have all the information I need when serialized. To do that, I've added 2 functions to every class I need to save. ToDict for converting to a dictionary with all the information needed to recreate it, and FromDict for reversing that process to rebuild the object. I start from Overlord, telling the universe to convert itself to a dictionary. In that process, it converts all of its contracts to dictionaries, all the population to dictionaries, etc. It's a lot of work to implement on a bunch of different classes, but fairly straightforward. Now here's where things get even more complicated. In many cases, the same object is referenced in multiple places. If I convert it to a dictionary each time, and then recreate it from that dictionary each time, I'll end up with multiple copies of the same object instead of those references pointing to the same one. In some cases, I can just avoid saving extra references to the same object. Ships hold a list of their crew, but instead of saving that list I could just rebuild it, with some caveats. But I found some cases where this proved difficult. As you may recall from a past video, each unit keeps a list of all the other units that dealt damage to it, so XP can be rewarded as a percentage of the final damage dealt. That was to account for shields recharging mid-battle. You don't know how much total damage it will take to kill a unit until it's over. I don't want to start redesigning mechanics of the game just to make saving easier, so I needed a solution to save and restore references without creating extra copies of the objects. Enter ref saver. It took a bit of work to integrate this with everything, but it's really very simple. When an object is created during the game, it calls a sign ID to get a unique numeric identifier. When it's time to save the game and something references that object, all I have to do is save that number. These objects also need to include their ID in the dictionary they generate for saving. Then at load time, each object tells the ref saver its ID. Now for the slightly tricky part. Let's say I'm loading a dock worker and it has an ID for the crate they were sent to pick up, but what if the crate hasn't been loaded yet? It might be later on in the save file. So instead of asking refsaver to find the object with that ID now, I've added a function called pendRef. This tells refsaver to fill in the appropriate reference later. Then at the end of loading the save, I tell refsaver to resolve all of those pending references. The only problem left was that list of who dealt damage to each unit used the object reference as a key in a dictionary. That's not so easy for refsaver to fill in later without some very specialized code, so instead I changed how this information is tracked at runtime. Now the dictionary key is just a numeric ID from refsaver. When it comes time to assign XP, I just use refsaver to look up the object for each ID. I still got some bugs to fix, and I have some more work to do on saving, like allowing you to have multiple saves, but that's as far as I got for this week. Next week I think I'll be working on the second equipment slot for crew, and adding things to equip there, but plans may change, especially now that I'm working with a bigger team. If you're enjoying this series, please consider liking, subscribing, or spreading the word. And as always, thanks for watching.